So, ladies and gentlemen, this is the test, right? I mean, yeah, it's a practice test, but all I did was I was creating this test and I just decided to print what I had so far and give it to you guys as a practice. Of course, I'm going to go back and change something out of each question, right? Maybe I change that plus 14x to a minus 14x, which would technically change the factorization of it. Anyway, so this is the test right here. Let's go over this test, which you're going to have to do on your own. Right here, what's the GCF?
14.
Yeah, 14. There's a multiple of 14 in every single term, right? There's 14 there. 14 times 3 is 42. 14 times 2 is 28. So 14 for sure. And the maximum amount of x's you could pull out of all three terms would be 3, right? That's the maximum amount of x's that you could pull out of all three terms, right? You can't really pull out any more because that's all you got. So 14x to the third is what you would pull out. And of course, you'd have stuff left over right here if you factored out the GCF. But this question, all it's asking for is the GCF, which is 14x to the third. So of course, it's not going to be exactly the same on tomorrow's test, but it's number one will be a GCF question. Number two, which of the following are factors? Okay, so the a value is 1. So I would set this up, and it might not even be factorable, but you need to think what times what is your c value that if you combine together is your b value. Okay, it's already been weeks that we've been doing this, guys. So hopefully we're going to be able to ace this on the test. And some of you are already telling me the correct factorization, but just in case you don't, for the students that don't know what's going on, make a list, right? How could you get negative 32, negative 1 times 32, negative 2 times 16, negative 3 doesn't work, negative 4 times 8, and that's about it. Now when you combine these numbers, negative 1 and 32, when you combine that, it gives you 31, and the b value is not 31, so that's not it. 16 and negative 2, that'll give you 14, and that is 14, so that's the correct pair of numbers that we want. So let's put a minus 2 right there and a plus 16 right there. That is the correct factored form. Now, I can't give this as a multiple choice answer because then you just distribute and see which one works. So I will ask you, if you see one of them, bubble it in. If you see both of them, bubble both of them in. So what's the only correct answer here? C. X minus 2. Now that doesn't mean that only one of them will be on tomorrow's. Maybe both of them are there tomorrow. Maybe tomorrow this is a plus 16 and you'd have to say B and C, right? Okay, moving on. Number 3, which of the following are factors of that guy? Again, same type of question. So let's set it up. X, make a list. What times what is 24? 1 times 24, 2 times 12, 3 times 8, 4 times 6, and that's it. Which pair of numbers combines together to give us the b value, negative 12? 3 and 8. 3 plus 8 is 11.
No.
So this is 11, that's 10, that's 14. None of them give us the b value. So what does that tell us? It tells us that it's not factorable, right? So E is the correct answer right there. It's not factorable. Number 4, which of the following are factors of this quadratic, perfect square quadratic binomial? So I want to emphasize this, guys. A perfect square quadratic binomial, it only has a possibility of being a perfect square quadratic binomial if there's a minus sign right here. Okay? So if you see a perfect square term and a perfect square term with a minus, this is from one of the old quizzes. If you go back to, I think, quiz 4.3, there was one question that I had a minus and one question that I had a plus. So the plus is not factorable. The minus is factorable. So let's do that. If you square root this guy, you'll get a 7x. So you put a 7x as a beginning part of each binomial. And if you square root this guy, you get a 4. So you put the second part as 4 on each binomial. And of course, because this is a minus, you will be able to put a plus and a minus in each of those binomials. That's the only way that the middle term, the b value, cancels out. That one's a positive, one's a negative. Okay, if this would have been a plus 16, then there's no way that the middle term would eliminate because this would have to be a plus 4 and a plus 4, or a minus 4 and a minus 4, and the middle term would not eliminate. So once again, let me repeat, if the sign right here were a plus sign, it wouldn't be factorable, even if you'd have perfect square quadratic trinomials. Make sense? So if I told you this on the test, 4x squared plus 9, and I told you factor that, what would you say? Not factorable. That's right. The only way it's factorable is if you have a difference of two squares. So that'd have to be a minus sign in order for it to be factorable. Okay, anyways, moving on. Oh, I'm sorry. Yeah, the answers. Let's go for the answers. 7x minus 4, 7x plus 4. So there's 7x plus 4, and there's 7x minus 4. Yeah, so definitely both A and D are answers. If you only see one of them, just put the 1. If you see both of them, put both of them. If you have it factored and you don't see any of them, then you say none of these are correct. All right? I mean, you found them, but they're not there, so none of them are correct. So keep that in mind. Moving on, number 5. This one, the A value is not 1. So we need to do step 1, which is what? A times C. So everybody, step 1, A times C. A is 6, C is negative 3, so we will get negative 18. Step 2, think of the multiples of negative 18 that combine together to give you the B value, which happens to be negative 7. So make a list. Negative 1 times 18, negative 2 times 9, negative 3 times 6, and that's about it. So which pair of numbers combines together to give you negative 7? Negative 2 and 9 will give you positive 7, but we want it to be a negative 7, so we have the right numbers. We just have the wrong signs, so let's change them to a positive 2 times a negative 9. This is the correct pair of numbers that we want. Everybody with me? And now, at this point, you could do factoring by grouping. You could change your 3 terms to 4 terms by replacing this middle value with these 2 values. Or the quick shortcut that I showed you is to immediately plug it into your factored form answer format with the AX right here and the AX right there. What's AX? 6x. And what do I do with this pair of numbers right here? Plug them in right there. So let's put that plus 2 and that minus 9. Now this is not the answer because obviously 6x times 6x is not 6x squared. That'd be 36x squared. So what do we need to do? Fourth step on the shortcut is magically divide, right? Magically reduce. The first binomial, you're going to divide this first binomial by what? 2. And the second binomial, I'm going to divide it by what? 3. So my first binomial will be 3x plus 1. My second binomial will be 2x minus 3. So there's my factored form. Which one's the answer? B. Only B, right? Okay. Do you guys remember completing the square?
Yeah.
Okay. Now this isn't applying completing the square when you're solving an equation. This is just that part of the worksheet where I told you find that perfect C value and then what would that factored form binomial squared actually be. And in order to do this, you need to remember that your perfect C value comes from taking the B value, dividing it by 2, and then multiplying it with itself. So what would this perfect C value be? Anybody?
64.
Positive 64, right? Because if you plug in that, the B value of 16, actually negative 16, divided by 2, and then square it, you'll have negative 8 squared, which is 64. So the perfect C value is 64, but they also want us to find the binomial squared. I hope we remember to find the binomial squared, you have x, and then what belongs in here with x? Anybody? Half of this value, half of the B value. So half of negative 16 is negative 18. I'm sorry, negative 8. What am I saying? Negative 18. Now keep this in mind, guys. This is a minus 16. Half of that's minus 8. If it would have been plus 16, then it'd be plus 8. If this would have been plus 20, then right here it'd be plus 10. If it were minus 20, it'd be minus 10. So the sign in front of your B that sign's going to be right there. Yay? Okay, so what's the correct answer on this one? E. And once again, guys, if this would have been a plus, would you be able to circle this answer? No, because that's a minus. This one has to be a minus. All right, keep that in mind. Number 7. If your discriminant is negative, then the parabola will cross the x-axis once, twice, 0 times, 3 times. 0, right? We need to remember the vocab here. It's right here on the wall. With quadratic equations, the answers are the same thing as the solutions, are the same thing as the x-intercepts, are the same thing as the roots. They all mean the same thing, okay? When we use the quadratic formula, which is x equals negative b plus or minus the square root of b squared minus 4ac, all divided by 2 times a, the discriminant is this value in here, right? And the quadratic formula gives us the answers. So the answers are the same thing as the roots, they're the same thing as the x-intercepts, where it crosses the x-axis. So if I get 2 real answers for this quadratic formula, then it's going to cross at 2 different places in the x. If I do this whole quadratic formula and I get imaginary values, then I don't get any real answers. I get imaginary values, which means I don't have any real x-intercepts, which means it doesn't cross the x-axis. If your discriminant would be 0, then you'd have the square root of 0, which is 0, and if you add 0 and subtract 0, it doesn't produce 2 different answers. You only have 1 single answer. So if your discriminant is 0, you only have 1 real answer, which means 1 x-intercept. The parabola only touches it once. So the question here is a discriminant question. How many times will your parabola cross the x-axis if your discriminant is negative? So if this value is negative, you'd have the square root of a negative, which means that it's imaginary, which means that you don't have real answers, which means that you don't have real x-intercepts. So the answer here is 0 times, right? It does not cross. Visually, that would look like this. The parabola is up here somewhere. It never touches the x-axis. Make sense? But you need to be ready for me changing this up. What do I mean by changing it up? What if I didn't say that the discriminant was negative? What if I said the discriminant was 0? Then how many times would your parabola cross the x-axis? Once. Because if this were 0, the square root of 0 is 0. Adding 0 does not change the number. Subtracting 0 does not change the number. So if I had right here like a 5, 5 plus 0 is 5, 5 minus 0 is 5. You're going to get the same answer. If you add or subtract 0, it does not produce 2 answers. So when your discriminant is 0, your parabola is going to like touch the x-axis only at one spot. Okay, so if your discriminant is 0, then it would touch it only once. What if your discriminant was positive? Then it would for sure be twice, because if you had a positive number in here, it doesn't matter if it's a perfect square number like 9 or even like 11. The square root of 11 is a decimal number. If you add that decimal number to whatever and then subtract that decimal number to whatever, it's going to give you 2 different answers, which means that it would cross the x-axis 2 times. Why? Because answers are x-intercepts. They all mean the same thing. So keep that in mind. If your discriminant is 0, it'll have 1. It'll touch the x-axis once. If your discriminant is positive, it'll cross it 2 times. If your discriminant is negative, you'd have an imaginary in here, or imaginary value, which means it doesn't cross at all. It doesn't touch the x-axis at all in that red one. Anyway, number 8, let's find the discriminant. What is the discriminant again?
The value
Inside the square root, the red b squared minus 4ac. So go for it. Do b squared minus 4ac. Okay, I recommend using parentheses whenever you plug in values. Let's identify the a value is 3, the b value is 9, the c value is negative 2. By the way, the only way you could identify a, b, and c is if it's equal to 0. So it is equal to 0, so we're good. So let's plug in the b value of 9. Let's plug in the a value of 3 and the c value of negative 2. So what we really have here is 9 squared, which is 81. Minus 4 times 3 is minus 12 times minus 2. That's a positive 24, which will give you the answer 105. So it's not doing the entire quadratic formula. It's only doing the inside of the square root. Bless you. Don't even put the square root on it. It's just 105. Okay? Number 9, which one's the correct quadratic formula? D? E. None of these are correct. What's wrong with D?
It doesn't have that minus in front of
Yeah, it has to be a negative b plus or minus square root of b squared minus 4ac divided by 2a. Okay, so keep that in mind. Be able to identify the correct quadratic formula. And I'm going to stop this video right here. That's half of the test right there, multiple choice. The other half is open response, and I'll make a different video for that later.